Hi, I'm Francesco Tisiot, developer advocate at Ivy. In this session, we will check out how you can create event-driven application using Apache Kafka and Python. First of all, if you are here at PyCon, I believe you will be somehow familiar with Python. But you may start guessing, why should I care about Apache Kafka? Well, I believe you will be somehow programmer, so you will be creating application, and most likely event-driven application. What are those? Are applications that as soon as an event happens in real life, they will need to know about it, they will start parsing it, and probably they will take the output of their computation and pass it to another application, probably event-driven, to create a chain of them. So why should you create event-driven application? Well, because we live in a fast world and we are used to have events happening every second. And we are also used to receive notification about those events. For example, when we receive a message, or when we make a payment with our credit card and we receive the related notification, or when someone else stole our credit card and makes a payment, we receive a weird notification about purchasing something that we didn't want to. And at the time that we receive the notification, we want to receive it immediately. We cannot wait like 6 hours or 3 hours or 20 minutes or 5 minutes of batch time. We want to receive a notification that our credit card was stolen immediately because we want to react as an event-driven application, and probably we want to call our bank in order to stop our credit card from being used. The same goes well with food. You know, I'm Italian, so I will, at a certain point of my talk, go into food, and it's better to do it now. When you take your phone, you open your food delivery app, you select the restaurant, you select the pizzas that you want, and you submit the order. That is generating a chain of event-driven application. First of all, your order will be submitted to the restaurant that will act as an application and start creating the pizzas for you. Once the pizza will be ready, it will be another event for the delivery people that will take to your home. Both the cases of credit card and delivery have something in common. You can understand that the value of the information is strictly related to the time that it takes to be delivered. With a credit card, I need to know now that my credit card has been used. With the delivery position of the delivery person, I need to know now where the position is. I need to know that in, for example, 10 seconds delay. I couldn't care less what the position was 5 or 10 minutes ago. The information needs to find its way in real time. So we need a component that makes this transmission of data, this communication, easy and reliable. And this is what Kafka is for. So what is Apache Kafka? Well, the concept of Kafka is really easy. It's a concept of a log file. A log file where event happens and they get stored in Kafka. So event 0 happens and gets stored. Event 1 happens, gets stored. 2, 3, and 4. Even more, it's append only and immutable. This means that once event 0 is stored, it's not like a record in the database. I cannot go there and change it. If something happens that changes the reality of event 0, I will have to add that to my log as a new event. Even more, Kafka allows us to manage multiple event types in multiple logs. For example, I have my pizza order log and my delivery position log. In Kafka terms, those are called topics. Kafka doesn't come with a huge server. Kafka is a distributed platform. So this means that when you create a Kafka instance, you are actually most likely creating a set of nodes of Kafka, which in Kafka terms are called brokers. And now your log information is stored in the brokers. And as you can see in the image, it's not stored once, but it's stored in multiple copies. The number of copies of each topic that are stored across brokers is defined by a parameter called replication factor. So we have 3 copies for our sharp edges log and 2 copies for the other one. Why do we do copies? Because we know that computers are not completely reliable. So we know that we could lose a node, but still we are not going to lose information. So we know that Kafka is a good platform to manage logs, but to manage events, but what is an event for Kafka? Well, for all what matters to Kafka, an event is just a key value pair. And the beauty of Kafka is that it doesn't care what you put in the key or in the value. It's just a series of bytes. So you could go from really simple messages like maximum temperature 38.5.3, or you could go pretty wild. For example, you want to include in both the key and the value JSON for the order that you are ordering, and specifying that on the key, the restaurant receiving the order and the phone line used to make the call, and in the value, the order ID, the name of the person making the order, and the list of pizzas. As you can see, you can specify that in any format. In this case, it's JSON, which is beautiful because I can read the whole dataset with my eyes, but it's pretty heavy when transmitted on wire because it contains both the field name and the field value for every field in your dataset. If you want a more compacted version of the same information, you could use Avro or Protobuf, which basically detach the schema from the payload and send the schema to a schema registry, which is used in order to compress the data, and also when you read the data to uncompress it. So now, how can we write to Kafka? Well, we know that we love Python, so we have our Python application that wants to write to Kafka. And in this case, it's called a producer. It writes to a topic. And in order to do that, it only needs to know three information. The first one is where to find Kafka, list of broker hostname and ports. The second one is how to authenticate. Do I need SSL, SASL, something else? Third one, how to encode the data from, for example, JSON to the raw series of bytes that Kafka understands. On the other side, I can read from Kafka, and if I have an application, Python, it's called a consumer. And how the consumer works is that it reads event number 0, and then it communicates Kafka, 0 done, let's move to 1. Read events number 1, communicates back to Kafka, 1 done, let's move to 2, etc., etc. Why communicating back is so important? Well, because we know computers are not reliable. So the consumer could go down. Still, Kafka will know until what point a certain consumer was reading a certain log. So the next time the same consumer pops up, it will probably submit the message number 3 because it was the last one not being read. In order to read data from Kafka, the consumer needs to know where to find Kafka, how to authenticate as before. Before we were encoding data, now we need to decode the same data. And we also need to know which topics we want to read from. All simple. Now, don't trust me when I tell you, trust me when I show you. Let's check with a nice Jupyter notebook that I created for you. What this notebook does, it's a series of notebook pages. There are more than one, which goes through several steps of Kafka. And the first one, it creates a Kafka instance under the Ivan managed services. If you want to see Ivan managed services, I created this Kafka Python instance for us, which is in Google Cloud Europe, Germany, but you can create your own instance pretty easily. You can select not only Kafka, but a set of open source data platforms. You can select one of the cloud providers available. Within the cloud provider, you can select the region and you can select the plan. Other goodies of Ivan is that you can upscale or downscale. You can move your Kafka cluster from one provider to the other. You can upgrade your Kafka cluster, and all those actions will happen while the cluster is still online, so you don't have any downtime. Apart from that, let's go back to our notebook. And we want to know how to push data to Kafka. So let's start a producer. First step, we installed Kafka Python, which is the library, the basic library that allows us to communicate with Kafka. Once this is done, we can create the producer. All we need to know is where to find Kafka, hostname and port. I'm using parameters, but you can put strings here, it's the same. How to connect, SSL using 3 certificates, and how to serialize, how to encode the data using from JSON to a raw series of bytes for both the value and the key. Let's execute this. Okay. Now we are ready to push our first record to Kafka. Let's put to a topic name with key id1, and the value is Francesco, myself, ordering a nice pizza margherita. I'm a simple guy, I want a margherita. Okay. Now the record is in Kafka. How can I check that? Let me create a consumer. Let's create a consumer over here and close. Okay, I want to create a consumer, so let's leave out the group ID for now. We will come back to this later. I create a consumer with named Clyde1, it can be anything. And the server security certificates are the same as before. Before I was serializing, now I'm deserializing from raw series of byte to JSON. All pretty clear. Now I can check which topics are available in Kafka. And I can see some internal topics together with a nice Francesco pizza topic. That is the one that I created for the purpose of this demo. I can subscribe to it. And now I can start reading. We can immediately notice a couple of things. The first one being that the consumer never stops. Well, because we are generating an event-driven application, so we want to be ready as soon as Kafka has a message for us to read from it. And in streaming world, there is never an end. The other bit which is interesting is that we push the order from Francesco ordering pizza margherita, but we don't see it on the consumer side. Well, this is because, by default, the consumer starts reading from Kafka from the point in time that it attached to Kafka. And we attach later than we push our first record. This is the default behavior. We will later see how to change this, but just bear in mind that this is the default. In order to prove that the whole pipeline is working, let me produce other two events. Adele ordering a pizza Hawaii and Mark ordering a pizza with chocolate. Now, you know, I'm Italian, so if you come to Italy and you order a pizza Hawaii, you probably will end up in jail. So I'm just telling you, I'm just suggesting you not doing that in Italy, but it's your choice. If you want a pizza Hawaii, you can deal with it. So let's try to send those two orders. Hopefully they will come across. Let's run. And we see that immediately we receive them on the consumer side. And we have the order both from Adele and from Mark. So the whole pipeline is actually working. Now let's go back to some more slides. So let's talk about the log size. We said that the log is stored in a broker. So this means that the whole log has to fit in a broker. This means that I have to have enough disk space in the broker to fit the log. Or on the other side, I need to reduce the amount of data that I want to store in the log because it has to fit on the disk space. This is a bad trade-off for a platform that wants to manage a huge amount of logs, a huge amount of topics, a huge amount of events. Well, luckily for us, Kafka doesn't enforce on us this trade-off. Kafka has knowledge of topic partitions, which is a way to logically divide events of the same time belonging to the same topic into partitions. So for example, our pizza orders, I could store all the pizza orders events of the same topic into separate partitions depending on the restaurant receiving the order. For example, Mario's Pizza on the blue one, Luigi's Pizza on the yellow one, Francesco Pizza on the red one. What is really stored in the broker is the partitions, not the whole log. So this means that the trade-off between disk size and partition is less worrying, because if I have a huge topic with a lot of events and a smaller disk space, I just need more partitions to fit in. How do you select a partition? Usually that is done with the key. Kafka by default hashes the key and ensures that messages with the same key end up in the same partition. Why selecting a partition is important because of ordering. Let me show you this little example where I have my producer producing data to a topic with two partitions, and then I have my consumer. In this example, we have only 3 events, blue, yellow, and red. And let's assume that while pushing data to Kafka, the events will land, the blue one will land in partition 0, the yellow in partition 1, and the red in partition 0 again. Now, when reading from the topic, it could happen that I will end up with the following sequence: blue, red, and yellow. Why is this? This is because once we start using partitioning, we have to give up on the global ordering. Kafka ensures the correct ordering only per partition. So when we start using partitioning, we need to make sure that all the events for which we care about the related ordering, that they will land in the same partition. So we understood that partitioning is good because of the disk trade-off and is bad because of the global ordering. But if we think about a topic with a single partition, it's just a unique thread appending events one after the other. So you can guess that the throughput is also due to this unique event happening, unique thread happening events one after the other. If we now have partitions, those are now, in this case, 3 independent threads. So you can start guessing that the throughput of those 3 independent threads writing events will be likely something around 3 times the original throughput. So this means that we can have a lot more producers start pushing data to Kafka. And not only pushing data to Kafka, we can also have consumers consuming data from Kafka. But still we want to consume all the events that are in Kafka, but we don't want to consume the same event twice. How can we do that? How Kafka enables us to do that? Well, Kafka will assign a non-overlapping set of partitions to consumer. This is a difficult word. Let me show you in this example. We have 3 partitions and 2 consumer. Kafka will, for example, assign the blue partition to the consumer 1 and the yellow and red partition to the consumer 2. In this case, basically Kafka ensures that all the messages are being read and none of the messages is read twice. So let me show you a little partition example. Let's go back to our nice notebook. So now what I will do, I will create a new producer. And let me show you. I created a new producer like the one before. And now I'm creating with Kafka admin client. I'm attaching to Kafka from an admin point of view with the same parameters as before. And I'm creating a new topic called Francesco Pizza partition with 2 partitions in this case. So nothing really complex. Before now pushing data to Kafka, let me create 2 consumers. So let me create a first consumer here, and let me start the consumer. And let me create another consumer at the bottom, and let me start it. Let me start this consumer too. Okay, I started both consumers. Let me double check. Yes, both are started. So now what happens? I have a topic with 2 partitions and 2 consumers. If everything I was telling you so far was true, since I'm now sending 2 messages with slightly different keys, ED0 and ED1, I would guess that those 2 messages will end up into 2 different partitions. So I should have my consumer, each of my consumers reading only from 1 partition, so reading only 1 record. Let's check this out. So let's write those 2 orders, and we can correctly see that only the top consumer is receiving only 1, and the bottom consumer is receiving only the other. If you wonder what those little flags means, this means that I'm reading from the partition 0, the offset 0, so the first record from partition 0, and I'm reading from partition 1, the offset 0, so the first record of partition 1. Now, if I send other 2 records, this time reusing the same key, so I would expect that mark order, since it's reusing the same key id equal to 0, will land in the same partition as Frank. And the same for Jan, landing in the same partition as Adele. Let's try this out. And it's exactly like that. Mark landing in the same partition as Frank with partition 0, offset 1, and Jan landing in the same partition as Adele, partition 1, offset 1. Everything working as expected. Now let's go back to slides. So as of now, we saw a pretty linear way of having 1 or more threads of a producer, Kafka, and 1 or more threads of a consumer. This 1 or more threads of a consumer were working one against the other to consume all the messages from a Kafka topic, but still they didn't want to consume the same message twice. However, when we consume a message from Kafka, that is not deleted, making it available for other applications to read. So for example, I could have my pizza makers that are working one against the other to read all the orders and to make them, but still they don't want to make the same pizza twice. On the other side, I could have my billing person willing to receive a copy of the orders in order to make the bills. How can I enable that? Well, with Kafka, there is a concept of consumer groups. So I can define my 2 pizza makers are part of the same application by saying they are part of the same consumer group, and then I define my billing person as part of a new consumer group. When saying that to Kafka, Kafka will basically take and send another copy of the data to this new application. And this new application will read the data at its own pace, which has nothing to do with the pizza makers one. Let's check this out as well. So if now we go back to the notebook and we go back to the original consumer and the original producer. And we take now the new consumer group down here. Let's close everything. Okay, so if we go at the top of the consumer, we had our group ID called pizza makers, which should sound familiar to you as of now. If we see the new consumer group, it's called billing person. So this is the way that we tell Kafka, look, that the bottom consumer is part of a new application that has nothing in common with the top one. The other bit that we can see here is that if you remember, we pushed 3 records, Francesco, Mark, and Adele, but we only saw 2 of them because we started our consumer later than when we produced the events. Now, when we create this new consumer, we are also telling Kafka, look, that I want to start reading from the log from the beginning with auto offset reset equal to earliest. This will allow us to connect to Kafka and to start reading the topic from the beginning. Let's try this out. Let's start our consumer. And now we should receive not only the original order, but also the other 2. There we are. We receive not only Adele's and Mark, but also Francesco order from the beginning. Now, if we also send a new record, a new event, done ordering pizza with fries, we should receive that in both applications, since there are those 2 distinct applications. Let's try this out. As we can see, done is present both at the top and at the bottom. So multiple consumer groups. Now let's finish off with some slides. So far we saw a lot of things. We saw how to produce data, how to consume data, how to use multiple partitions, how to define multiple applications that consume data from Kafka. However, we had always to write our own code to produce and to consume data. The reality is that most of the times we will include Kafka not in a greenfield project, but in a data project with a lot of data systems already available. And we want to quickly integrate Kafka in them, possibly without having to reinvent the wheel writing our own code. This is where Kafka Connect plays a huge role. Kafka Connect is a pre-built framework that allows us an easy integration of Kafka with existing ecosystem. So for example, I have my application writing data to Postgres database, to Cassandra, to Google PubSub. Well, with Kafka Connect and just a config file, I can take any changes happening in one of those source systems and propagate them as events, as messages in a Kafka topic. I have data in a Kafka topic, and my users are using BigQuery, Elasticsearch, Postgres. I can take the data from a Kafka topic and with Kafka Connect push the data, push several copies of the topic data to a lot of data sinks. Do I want another copy for long-term storage in S3? It's just available with Kafka Connect. The beauty of Kafka Connect is that it's just a thread, which in case of Ivan is also managed for you. And you just have to write a config file telling which is your source and which is your target. For example, if you want to sync data from Kafka, which is the topic that you want to sync from, and which is your target. For example, the details of your BigQuery. Some more resources that I believe you will find useful. The first one is my Twitter handle. Message me, my messages are open for any question regarding Kafka and Python or any other open source technology that Ivan provides. Second thing is the URL to the notebooks that I've been showing you. You can find them in GitHub, public, and you can do the same stuff that I've been doing, even more. The third thing is if you want to try Kafka but you don't have any data, well, check out this GitHub URL because it contains a Python fake pizza provider. So it starts creating pizza orders, which are way more complex than the ones that I've been showing you in this demo. The last bit is that if you want to try Kafka, but you don't have Kafka, well, go to ivan.io, because we offer that as a managed service, and you can redeem the $300 of free credit that lets you start your journey in Kafka. I hope you find this session useful and you will start your journey in Kafka soon. Thanks a lot, and ciao from Francesco.